Hi everyone, welcome to Prep Fusion. So in this video we are going to solve a very good question on analog electronics, you can say, or you can say it will require the concept of transient analysis as well. So analog and network both combined are there. Okay. Now the thing is, there is 1 volt of battery. There are two switches, Q and QB switches are there. Then there is this RC circuit, and the capacitor is having a voltage of V0, and that V0 voltage is fed as an input to non-inverting Schmitt trigger and inverting Schmitt trigger, and those non-inverting and inverting Schmitt trigger is giving Q and QB as output. So those Q and QB are running those switches. Are you getting this point? So output of Schmitt trigger could be either 1 or 0. And what does that mean? If QB is 1 or Q is 1, that means switch is on. If both are 0, that means switch is off. Basically, Q equals to 1 will turn this switch, it will turn this switch on. If Q equals to 0, then it will be off. If QB equals to 1, then it will turn this switch on. If QB equals to 0, then switch will be off. So I hope the question is clear. They have given the threshold voltage of Schmitt triggers as well, that is 0.25 volt, 0.75 volt as well. And saturation voltage is 1 volt and 0 volt. What does that mean? Their output could be 1 volt or 0 volt. You need to find the frequency of oscillations at Q, QB, or they could have asked at V0 as well. Now in this question, I did not give the characteristics. I have just written the name, non-inverting Schmitt trigger. So yesterday I took a session on op-amp in positive feedback. There I told you it is not necessary that they will give you the characteristics. They can directly write down the name as well. In GATE 2021, there was a question in electrical. There they did not give the characteristics. They just told that it is a inverting Schmitt trigger, and then they give the threshold voltages. That's it. And they also told the saturation voltages as well. So it is not necessary that characteristics will be given in the examination. So you should know how to make the non-inverting Schmitt trigger characteristics, how to make the inverting Schmitt trigger characteristics. So for that you need to watch yesterday's session. But if you know how to make the characteristics, then you can proceed with this particular video. So let's first make the characteristics, because without characteristics we will not be able to solve this question. So for inverting and non-inverting we need to make. So first we are making for non-inverting Schmitt trigger. So what did I tell you? There will be a dead zone. So first that dead zone we will make. Output could be 1 volt and 0 volt, and thresholds are 0.25 and 0.75. Everything is positive. So this is how the dead zone will look like, right? Here this input voltage, if it is 0.25, then it is 0.75. This I am making for, look here, the input of Schmitt trigger is V0, right? Input of Schmitt trigger is V0. So here I am writing V0. And output of non-inverting Schmitt trigger is QB. So here I am writing QB. Are you getting this point? Right? Then if it is non-inverting Schmitt trigger, what do you mean by non-inverting Schmitt trigger? That for higher voltage it will give higher output, and for lower voltage it will give lower output. Right? In that manner. Okay. And what will be the direction of rotation? Since it is non-inverting, that means direction will be anti-clockwise. Direction will be, let me use another color of pen. Direction will be anti-clockwise. Non-inverting will have anti-clockwise direction, because I told you everywhere whenever we take angle we go anti-clockwise. Whenever we talk about nothing that is being inverted, that means if we talk about positive thing, what does that mean? If we are talking about positive, that means anti-clockwise. So this is how I will make the characteristics, and here both sign of arrow will come. Both sign of arrow will come. So this is the characteristics of a non-inverting Schmitt trigger, and you should know how to read these characteristics. That also I have told. You will work from here to here in this manner, and then you will work from here to here in this manner. Okay. Here both kind of arrows are there. So both kind of arrows we are making. Right. Now let's make the same for inverting Schmitt trigger as well. So for inverting Schmitt trigger, this will be the same, but the difference will be, this difference will not be there. Both will be having the threshold voltage of same threshold voltage is there, but the difference will be, since it is inverting Schmitt trigger. What is the meaning of inverting Schmitt trigger? That for higher value of voltage you will get lower output, for lower value of voltage you will get higher output. And how will be the rotation look like? It will be clockwise, right? Okay. And here both sign of arrow would be there. Here both sign of arrow would be there. And output, positive output is 1, lower output is 0, positive output is 1. So this is the characteristics. Now what is the initial condition? Initially there is no charge on this capacitor. So this is having 0 volt. Now this 0 volt will be fed here. This 0 volt will be fed here as well. So at 0 volt, if input is 0 volt, that means if V0 is 0 volt, this guy is saying that you should go to, QB should go to 0, and this guy is saying that Q should go to, what is this output? This is your Q. ambiguity will be there when you are in the dead zone. When you are in the dead zone, at that time ambiguity will be there. But now if your input is 0 volt, if your V naught is 0 volt, that means if this is 0 volt, then QB is saying that you should go to 0 volt, your output should be 0, your output should be 0, and Q is saying that I should go to 1 volt. So when at the initial condition, this guy is going to 0 volt and this guy is going to 1 volt. So this guy is going to 1 volt here. Wait a second. What is the issue? Okay. Sorry. I just made it opposite, right? QB is saying to go to 0 volt. QB is saying to go to 0 volt. Yeah, and Q is saying to go to 1 volt. Q is saying to 1 volt. Yeah, okay. Fine, it is fine only. So QB is saying to go to 0 volt. That means it should be open. It should be open. And Q is 1. That means it should be closed. That means this will turn on. Q is 1 means it will be closed. It will turn on. So now 1 volt will be coming here. Basically, this battery will be turning on now. Now this 1 volt will be coming here. Now what this 1 volt will do? Look, this will be made from op amp. So this will drive 0 ampere current. These are ideal, so they are driving 0 ampere current. So because of 1 volt, whatever the current will flow, that will flow from the capacitor only, no? So now this 1 volt will charge the capacitor. So capacitor will develop some charge. So that means your V naught is going up. Your V naught is going up. From 0 to a certain value it is going. So if your V naught is going up, that means you are moving in this direction now. You are moving in this direction now. So which characteristics you will follow? This characteristics I will follow now. If my V naught is going up, so this characteristics I will follow. Here I will follow this characteristics and here I will follow this characteristics. So now what both of the characteristics are saying? Both of the characteristics are saying that the transition will be at 0.75. The transition will be at 0.75. So both of the characteristics are saying that if your V naught is 0.75, at that point there will be transition. So until you reach 0.75 volt, till that point there will be no transition. That means till that point your Q will be 1 and QB will be 0 only. Say yes or no. Right? All good? All fine? Okay. So now the scenes are, your V naught will start developing the voltage. What your V naught can see, what your capacitor can see, that 1 volt is applied. So your capacitor can see 1 volt is applied. So your capacitor will start developing the voltage. It will try to go up to 1 volt. So your capacitor will try to go up to 1 volt. Capacitor will try to go up to 1 volt. And what is tau here? Tau is RC. Tau is RC. 2 nanofarad, 1 kilo ohm. That will be 2 microfarad. Sorry, 2 microsecond. So this will be the same. But there is a transition. There is a transition at when your V naught becomes 0.75 volt. So till the point 0.75 volt we need to analyze, because after that there is a transition. That means after that the circuit condition is changing. After that what will happen? QB will say that I will be 1 and Q will say that sir I will be 0. That means QB will say that now I will be turning on and Q will say that I will be turning off. So circuit condition will change. So capacitor equation will also change. So until the point we reach 0.75 volt, till that point we need to analyze it. Are you getting this point or not? Here the concept of multivibrators are being used, but don't think anything. Multivibrators, what is multivibrator? If you don't know, still you will be able to solve the problem. Right? Even if you don't know what is multivibrator, still you will be able to solve the problem, because this is simple RC circuit, charging, discharging. Multivibrator is nothing but it is a Schmitt trigger with RC circuit, nothing else. That's why I took this question, so that your concept of multivibrator gets cleared. So what is happening here? Until you reach 0.75 volt, there is no change in the circuit. That means capacitor is getting charged. But after 0.75 volt, there is a change in the circuit. So circuit condition will change. After that, we need to analyze again. So now capacitor is developing the voltage. But till what point it will develop the voltage? Until it reaches to 0.75 volt. Okay. So now till what point, till what time? So this time will be, you can calculate it, ln 4 into 2. 4 ln into 2. So this time is 2.77 seconds. So what do you see? Initially what is happening is that your capacitor is getting charged. This V naught value is getting charged. Your V naught is getting charged. Right? This V naught is getting charged and it was charged till 0.75 volt. It was charged till 0.75 volt. And in this condition, what was the condition? Your QA was 0, I guess. Sorry, QB was 0 and Q was 1. This is your QB and Q. So in this condition, your QB was 0. So till this point, till this particular point, your QB was 0. Your QB was 0 and Q was 1. Right? Let's see what happens next. Now, just as it goes above 0.75, let's just say it goes to, now the capacitor is charged to 0.75. Okay, let's remove this 0 volt, 0 volt. This I already know it will drive 0 ampere current. Let's remove this off. Now let's remove this off as well. Okay, so now what is the, this 1 volt was there, but now it is charged to, let's just say 0.76 volt. So now at 0.76 volt, what will happen? At 0.76 volt, QB will say that, sir, I will be 1, and Q will say that, sir, I will be 0. That means Q is saying that, sir, I will be 0. That means I will be open now. And QB will say that, sir, I will be closed. So now here 0.5 volt only reached. 0.76 did not reach. After 0.5 only, they started saying that, sir, I will be open and I will be closed. Now what is the equivalent circuit here? This is connected to ground, right? This end of resistor is connected to ground. So this has become simple RC discharging circuit, right? Now from the capacitor, current will flow and it will discharge the capacitor. Capacitor has only one path to flow. This is the only path, because input of op-amp will drive 0 ampere current. So capacitor will discharge from 1 kilo ohm only. So capacitor is having only one path to discharge. So now it will keep on discharging. That means my V0 is going low. From 0.75 to, it will try to go to 0. Capacitor will try to discharge completely. So from 0.75 volt to, it will try to go to 0. But will it be able to reach 0? Let's check that out. So what will happen? Now your input is decreasing. Now you are going from 0.75 volt to 0. 0.75 volt to 0. So that means you are moving in this direction. So which characteristics you will follow? This characteristics you will follow. You are moving in this direction, right? You are moving in this direction. Which direction? In this direction you are moving. So this characteristics you will follow now. So in this characteristics, where is the transition? The transition is at 0.25. This characteristics was there, and here this characteristics was there. So where is the transition? The transition is at 0.25. Right? So now your V0 will go down. Your V0 will go down till it reaches to 0.25 voltage. Right? So initially your V0 is, as of now, at 2.77. At 2.77 seconds, your V0 is having 0.75 voltage. Now what will be the equation of V0? V0 will try to, from 0.75 voltage to, it will try to go to 0 voltage. So this will be the equation, discharging equation. It will try to go to 0 voltage, but from where we are starting our circuit? We are starting our circuit from 2.77, no? Yeah, 2.77 seconds. This is in microsecond. This is in microsecond. Since we are starting our circuit from 2.77 seconds, so here I will put 2.77 microsecond. Okay, divided by, although it is not required to put this 2.77 microsecond, you can solve with respect to t as well. In the examination, we will solve with respect to t only. So this method I again and again teach you that you should solve with respect to t only. Basically, from 0.75 to, you need to go down to 0.25 volt. So how much window of time you require? Based on that you can solve. So what was that time period here? It was 2 microseconds. So now till what point it will go? Till 0.25 it will go. So till 0.25 it will go. E to the power minus. So you can simply solve it, whatever the value you get. So you can solve it 1 by 3 ln 3 ln 2 into ln 3. So 3 ln into 2 plus 2.77. So it will discharge till 4.96 seconds. So basically here it will discharge till 4.96 seconds. Till 4.96 seconds, and the voltage it has reached, that is 0.25. That is 0.25. Okay. So what is the value you are getting? 4.96 volt. 4.96. 4.96 microsecond. So now in this window your QB was 1. In this window your QB was 1. In this particular window your QB was 1. but your Q was 0. Okay. Now what will happen? Now let's just say your V naught was going down. Now it has went down in a manner that it has reached to 0.24 volt. It has reached to 0.24 volt. Now if it has reached to 0.24 volt, then what this characteristics will say? 0.24 volt. 0.24 volt will be here. So this QB will say that sir I will go to 0, but this Q will say that sir I will go to 1. So Q is saying that sir I will go to 1. That means now the switch will be turned on. So this switch will be turned on and this will be off now. What will happen now? This 1 volt will be coming here, but this capacitor is already charged to 2.5 volt, right? So now the V naught value will go up from 0.2, not 2.5, actually 0.25. So now this V naught value will go up from 0.25 to it is going up. So if it is going up, then that means which direction I need to follow? This direction I need to follow. Which direction I need to follow? This direction I need to follow. Since your V naught value is going up, that means input of Schmitt trigger is going up. So now I will follow this characteristics, right? Which characteristics I am following? This characteristics I will follow. So in both of the characteristics, where is the transition? The transition is at 0.75. So now your capacitor will say that sir I will charge up to 0.75. No, capacitor will say that sir I want to charge up to 1 volt only. But these characteristics will say that you can charge up to 0.75 only, because after that the circuit condition are changing. After that what will happen? Again QB will be 1 and Q will be 0. That means again again this will be on and this will be off. So are you getting to know that what is happening with the switches? On off, on off, on off. At one time one is on, at the other time other one is on. One is charging the capacitor, other one is discharging the capacitor. So there is kind of oscillations. So that frequency of oscillations they are asking. So now in the next cycle you will be able to understand what is happening. You need to go from 0.25 to 0.75. But you need to go from 0.725 to 1 volt. Capacitor will say that sir I will try to go to 1 volt. I will try to go to 1 volt and my initial condition is 0.25. So what will be the equation? These equation you should be having habit to write down. So capacitor is saying that I will start from 0.25 volt and I am trying to go to 1 volt, right? But in between, where it will try to, at what point it will stop? At 0.25 volt it will stop, because after that the circuit condition will change. Say yes or no? Sorry. It is okay. It is rising. Sorry. Where it will stop? At 0.75 it will stop, because after 0.75 volt, where is the transition? The transition was here, no? At this point the transition was there, because now input is increasing. If input is increasing, that means transition is here. Transition is at this point. Transition at this point. So when you reach 0.75 volt, it will stop. Here what you are going to write? From where you are starting your circuit? You are starting your circuit from 4.96. You are starting your circuit from 4.96 divided by your time period, that is 2 micro. Okay. So now I can solve this equation and I will get the value of T from here. So this I need to equate to 0.75 and then this is how I will solve it. So 3 ln into 2 plus 4.96, 7.157. So T value I am getting is 7.157 seconds. Okay. So basically here what is happening? Now this is getting charged. Till what point it will charge? Till 0.75 volt it will charge. Then again the same circuit condition we will get. Which circuit condition we will get? The same condition that you got here. What will happen? Now what will happen after this point? Till this point what is the scene? That your QB is off and your Q is on. That means capacitor is getting charged. But since you have reached 0.75 volt, after that what will happen? Let's just say next condition is 0.76 volt. So at 0.76 volt, this guy will say that sir I will go to 1. QB will say that sir I will go to 1 and Q will say that sir I will go to 0. So if Q is going to 0, that means this will be off and this will be on. That means capacitor will discharge. So again capacitor will discharge, but it can discharge up to 0.25 volt only, because after that again circuit condition is getting changed. So now you are able to read the characteristics as well. You are able to understand the meaning of characteristics as well, and in that manner you are able to solve the problem as well, right? So now you can see that there is constant charging, discharging, charging, discharging. So this will be your steady state cycle. In that manner, charging, discharging, charging, discharging is there. Okay. They are just asking frequency of oscillations, which is pretty easier. So here which window we got? We got the time window to be 7.517. 7.157, no? 157, 157, 7.157. So this is your time period, right? This is your time period. This is not the steady state. This was just the one state. After that, this is the steady state. Actually, what will happen is that now it will not go below 0.25, right? It will not go below 0.25, then till 0.75, then again in this manner, then again in this manner. It will keep on going like this, right? It will keep on following this path. So this window is being repeated. This window is being repeated. This window is being repeated, right? 7.157 minus 2.7 minus 2.77. So that is 4.38. 4.38 microseconds we are getting. So this is the time period, that is 4.38 microsecond. And if they are asking frequency of oscillations, then just you take the reciprocal. So 227.93. 227.93 kilohertz. So this is the frequency of oscillations. So this is the final answer. A very good question it was. Okay, and I hope you enjoyed the analysis. So this is how it will go. So you should know how to draw the characteristics of non-inverting Schmitt trigger. Again and again I am saying, in the examination it is not necessary that they will give the circuit. It is not necessary that they will give you the characteristics as well. They can just mention the name and they can give the threshold voltages and the saturation voltages. So it should be you who needs to draw the characteristics, and it should be you who needs to understand the graph, that how it goes. So in the last video only where I taught Schmitt trigger, there I told you how to read these graphs. So this is where we started from. We did not start from Schmitt trigger. We started from here, that how to read these graphs. Then we went to Schmitt trigger because our target was to make these graphs using Schmitt trigger. So that we made. And then there is another concept, that is of astable multivibrator's. So that is the same kind of concept. You will use a Schmitt trigger there, and then you will apply RC circuit there. And then the capacitor will charge and discharge, and based on that your output will keep on oscillating. And if your output keeps on oscillating, so it will be a oscillator, and based on that they will ask you the frequency of oscillations. So you can analyze the circuit. Now I hope I have given enough concept. Since this was a revision video, these were revision concept. So now I don't think I need to bring another video based on astable multivibrator. So now you can analyze it on your own. And secondly, I am not asking for views, but the last video got a very less response. I don't know why. There I taught amazing concept of Schmitt trigger, but still that video got a very less response. So I think it is not required. I'm not saying that I need views as of now, because it's you guys, you need to study, because your examination is just after 7 to 8 days. So I don't need views. I'm not asking for views. I'm just saying that it feels like that it is not required. So as of now it is not required. Then I will bring something different. Like people were asking for oblique incidence, so that I can think of bringing. Okay. So yeah, and if you want to solve these kind of problems, like these kind of very good problems in your if you need to solve, like if you want to revise your notes, if you want to revise the questions, and if you want to solve these kind of problems. So this was just one question. There are a lot of questions like this. There are 400 questions here. 400 questions from 5 subjects. Okay. So you can solve these questions. Like every particular question will require 2 to 3 concepts combined. And after these 400 questions, at least 370 questions, or at least around 350 questions, I and Anish sir have personally framed. Okay. Either we have framed it or we have got from NPTEL lectures. So these are very good questions. Like people will find it tough, but they are very conceptual, and not a single concept is out of the syllabus, because we ourselves are framing the problems. No. So nothing is out of the syllabus here. Like in this question, will you call it out of the syllabus? No. A lot of people will call it out of the syllabus because they are not able to solve it. But non-inverting Schmitt trigger, you know, inverting Schmitt trigger, you know, RC circuit charging, you know, switch, you know. So what is out of the syllabus here? Here I am not framing anything that is not even mentioned in the syllabus, like a random formula based question. No, here you will never get any random formula based question. All are conceptual problems here. So try solving it, and you will certainly get your subject on a next level. Okay, the understanding will be on next level, that I can guarantee after solving this particular playlist. Thank you very much. Let's meet in some other session. Yeah.